How are you feeling? This is the interactive session. So if you can show me some love, yeah, we'll go. How are you feeling? I like that. Better? How are you feeling? Kenyans, I can say Kenyans there, but they're not here. What's problem? Yes, I like. Yes, so this will be a very interactive session because I'm very sure most of us don't have experience in cybersecurity. Or do you? How many of us in your school, at least you've been taught some bit of cybersecurity? Okay, keep your hands up, baby. Because it means cybersecurity. Okay, so what have you been taught in school? What's cybersecurity? You. Yes, you. You can learn up here, and then you can just jump in. We are all learning together, isn't it?
Thank you. I'm not much into cybersecurity, but what I know about cybersecurity is all about the protection, the protection that you can use on your platform. Yeah, that you can use on your platform or websites to prevent attacks. Yeah, that is the part I want.
That's been more than enough. Give him a clap, please. So today we are going to learn about the art of defensive programming. My name is Jirui. I'm a senior cloud security advocate at Microsoft. I've been an ethical hacker for more than 10 years. And prior to that, I was a software developer. I got into cybersecurity. Long story short, I got hacked. Yes, so one of the projects I was building was compromised. That's why I got really curious about how to build more secure products. And that's what I've been doing in the last couple of years in terms of training developers to build more secure products. Okay? Is that something you're interested in knowing? Is that something you're interested in knowing? Yes! I still don't need the t-shirt, Josh. Yes, that one. Okay, let's dive into it. Yes, so, it's secure code. Secure code everywhere. So yes, so let's just look at a bit of stats, yeah? These are latest stats. Like 52% of companies actually usually sacrifice cybersecurity for speed. How many of us are not students, like you're actually working as a developer in a company? 1, 2, 3, 4, 5? 5 people? And then the rest of us are students? Yes! Okay. So I can ask you a question? So how do you handle between you as a developer and the security team within your organization? Can you just come? Yes, sorry. I think I prefer interact so you can know also how companies in Uganda are doing it wrong. So how do you integrate within the developers and the security team? How do you work together?
So it gives updates on security. It reminds us to secure our devices every sprint, at the end of every sprint. We also get security training from the Linux Foundation.
What kind of training?
Course.
So, like, is it only on your operating system? Is it on your
developing secure software.
Okay. And does the security team also do some code review of what you've actually built?
Most of it is through automated tools, like SaaS tools and things that are in Python.
Yes, you should be here. You should be here for that. Huh? That's nice. So, like, what kind of SaaS tools do you use?
For what?
So it means you don't use it daily?
Well, that is the beauty of automation. I don't have to think too much about it, but the analysis is being done.
Okay, thank you. Thank you. Josh, t-shirt, please. Thank you. Let's give me a clap, please. So yes, having worked with this industry for some time, the way developers see cybersecurity teams is they see them as gatekeepers. But right now, at least we're adopting more and more automation so you can identify security vulnerabilities as early on as possible in your software development lifecycle. So I'm going to take you through that. So we also see 57% of ops teams, they push back on security best practices. Some companies still use some legacy systems. So by the time the security review is done by the security team, they have generated like 5 pages of security vulnerabilities and given them to the ops team, and they're supposed to patch them before the system goes live. Which in some cases they can't comply to everything. So there's a lot of pushback. And then we're seeing 44% of developers are not trained to code securely. These companies are unique one. Because also this is something that we are facing globally. Very few organizations actually train the developers on shifting security left and thinking about security fast. Okay? That's why we're training you on this today. So you can carry this even in your workplace, in your day-to-day. So let's, I don't know if you were here on the first day for the keynote. So where they say Python is the second most used language because we are supplementing other programming languages. And in most cases as well, when you're building a particular system, you are actually borrowing a lot of code, what you call open source dependencies, third-party dependencies, open source components, yeah? So 80 to 90% of our system is actually borrowed code. So you might be wondering, so what am I actually borrowing into my system? Are they actually secure? How do I know if they're secure? Because the way we look at security, you have a very beautiful house. I'm sure some of you want a very big mansion, yeah? So you can imagine you have a very big mansion, and then you're living in that mansion without any door or any windows. For anyone to just walk in and take anything they want. So that's security in case. So we are putting safeguards in place to make it very hard for people to compromise and take away your assets. So other sources of vulnerabilities, apart from the 80 to 90% of borrowed code that we are integrating within our code base, is employee error. I usually say, developers actually know when they have done something bad. Like I'm sure if I ask you if you've actually coded within the best practices, you'll be like, yeah, I know I did something wrong somewhere, isn't it? So yes. Employee error is usually among the top issues as well because we've seen a lot of exposed access tokens, API keys, hard-coded passwords, getting code base. And also, so the damage is usually a lot more when features in production. So you've seen the SDL stages from develop, build, test, deploy. So once it's deployed and a security vulnerability is found in production, the cost is usually a lot more. So it might not be a financial cost, but it also might be, so you may find that data that's breached for your organization. That means that your reputation is at risk, okay? And in also some cases, yes, it reaches some financial aspect as well. So this is why we talk about shifting security left. Because shifting security left actually reduces the security costs and incidents throughout and moves it also up to the development phase of software development. So this leads to 80% reduction of security incidents. So you have less of them once you are in production. Okay? We have 60 times less costs because it's usually in the millions. Okay, you get the let's say trillions. When it's in production. So you have to really integrate security automation as early on as possible. And then we are also saying like, we're still very low in terms of adopting automation throughout the software development life cycle. So we have two because of that. So if you forget anything, remember this. So this one is a summary of the software development life cycle and how security fits into that field. So we break it down into the pre-commit. So this is before you actually commit your code, and when we are in the pre-commit phase, we do something called threat modeling. So Microsoft has an open source tool called Microsoft Threat Modeling tool. So we usually try to emulate what an attacker would use to compromise your system, and you find ways of fixing that before you actually even develop. And then we have IDE security plugin. So this is your typical VS Code. So when you go to extensions on your extreme left, depending on where you put it, and then you just search for security, you'll see all these extensions that are for security. So some of them, this is where this very important shape left. You are able to integrate security in your IDE, and then it gives you security vulnerabilities whenever you're coding. Okay? So we have several. So like for Python, there's an inbuilt one by Python called Silent, which gives you source code review, so you can be able to find security vulnerabilities. We also have a popular open source one called Bandit. I hope you're written down, so at least you can go in and try them out. So Bandit is also a very nice open source tool for Python, where it can give you third-party component vulnerabilities, as well as your code vulnerabilities as well. So in the pre-commit, you also look at secure coding standards. So we have secure coding standards that are in place as well. So we have like the OWASP security standards, which you should be able to go in and just learn from what they are recommending. And we also have peer review to identify who is reviewing your code as well. So after that, an important thing that you need to do as well in the pre-commit is the pre-commit hooks. So pre-commit hooks, determining with what you've actually configured, it might be, if you have secrets within your code, it will refuse for you to actually commit your code. If you have security vulnerabilities, it will refuse for you to commit your code. That's why it's very important to have pre-commit hooks. A popular pre-commit hook that you can integrate within your VS Code is called pre-commit. You can just say install pre-commit, as this is that. Okay? And then when you come to commit, we are looking at static code analysis. Static code analysis is 20% of the code that you've actually developed yourself. So it gives you security vulnerabilities for the code that you built yourself. Security unit test, it breaks down your application into tiny bits just to find if there's any vulnerabilities by putting some stress tests as well and unit tests in terms of security review. Dependency management is looking at the borrowed code, the 80% of the borrowed code that you have, and find security vulnerabilities, and then you can be able to fix them. And also credential scanning for the secrets that you've already committed within your code. And then we have the deploy. In the deploy stage, you look at infrastructure as code, because nowadays we are doing a lot of automation. Even for spinning up infrastructure, we spin it up as code. So even if you have like web servers, you have your database, you can spin them up as code. And then you have dynamic security scanning. So the difference between dynamic security scanning and static code analysis or dependency management is dynamic security scanning will do a lot more attacks on your code to find more security vulnerabilities. Popular open source dynamic security scan is called OWASP, which you can just install and try and play around with it. So yes, that shows you on IDE integration. And then we also have GitHub Advanced Security. So for GitHub Advanced Security, this is so I want you to just review this code. I just wanted you to come closer to review this code and tell me if it's secure. You're saying reverse?
Session cookie.
Session cookie, what's wrong with the session cookie?
It's stored in EES.
It's stored in EAS. Uh-huh.
That's not secure.
You're almost there, huh?
That's not secure.
Yeah, that's not secure, yes.
Then number 4, the username and password are the same.
Username and password are the same? Okay. Yes?
The second user's password is not included.
The second user's password is not included.
Encrypted.
Encrypted. It's not encrypted.
Yeah.
Okay, you're almost there, yes?
The password is in clear text, probably it should become a
Okay. Yes. In a way, you're definitely right. But the first line, it's even wrong even from the first line. So from the first line, here we see that we're using alias in ECB mode. So that's an encryption algorithm which is very insecure, which you should never use. So should you be worried about security when you're building your code in Python? Is it something that you think is a priority for you? It is? Okay. Then I think we only have five minutes, so I think I'll just leave the other slides for questions. So at least you can, I know you have probably some challenges or source code review or whatever. I'm open to questions. Yes?
Hello, my name is Pycon Uganda. Can you please touch on security and
So we'll be touching on how to create your own secure chatbot, and you'll be, yes? You'll be having a talk here. Okay, look at me for me on the other side. But yes, so yes, in terms of AI security, we look at a couple of things. The one thing that we look at as well nowadays is what we call prompt injection. And we also look at Trojans within your chat application as well, because whatever you're feeding it, you don't know if it's able to ingest if it's actually malicious. Okay, so prompt injection is whereby you can give a particular command, you can tell it probably to give you a password, it should not give you a password, so we want to do all those injections to see if it will give you sensitive data. Yeah. Another one.
how do you protect, let's say, build a chatbot? How do you protect it from data poisoning?
By training it. So you need a particular data set showing that these are all malicious actions. So it goes in and checks against that set to determine if it's actually malicious. So like for example, if it's like for checking if it's for prompt injection for passwords, you're feeding in a particular data set. There's some that are open source, so you feed it in and then you test it. It's just more of training, yeah? Any other question? Yes, hi Sam.
Hi, very nice to meet you again. So, thank you much for the presentation. It was really interesting and confusing for me because I'm not into cybersecurity so much like that. So, I just wanted to ask about the programming language that you can use to check buffer overflow. Because last time at school we were in a competition and then we were trying to use ESP32 port, it's an electronic one. And then it was a cybersecurity competition and the other team attacked our network using Wi-Fi stuff, Wi-Fi security stuff. And the guy overloaded our chip by allocating memory, like extra memory to our environment. So it kind of blocked our code and we couldn't do anything. So which programming language is well used? And can we use for defensive coding in that kind of time? Because in Python it's very hard for me to access pointers. It's kind of hard, like memory addressing is really hard when I'm using Python. So
So it's already done for you. It's already done for you, it's already built, even using Python, and there's also some using Ruby on Rails on Kali Linux to test for buffer overflow.
Okay.
Yes. It's already there. You don't have to reinvent the wheel for sure.
Yeah, because it was really hard to actually access the memory of the hardware using Python code. Thank you so much.
Yes, so I can just show you how to research for buffer overflow from Kali Linux. How many of you?
For me, to be more, the situation now is that we use a lot, or I use a lot of third-party services. Yeah, so I'm more into WordPress, but the hack which is now happening is the Japanese hack where the client finds the website in Japanese things. So how can I, like, how do I stop it? Because I'm using more third-party tools and I'm not very good in checking for the guy just goes, wait, my site is off, I've seen Japanese things. So how can I, yeah, because I use more third-party things, so how can I, yeah, some.
Okay. Are you using third-party tools or tracked tools? So because I've seen many of us, including like me when I was a student, because I couldn't buy all those commercial tools, I would download them in the cracked version. So the thing with the cracked versions, they have malware embedded on them. That's why you can see like Windows prompts coming up and disappearing. So you might be having that server that's transmitting, that's receiving whatever you're writing to them. Yeah? So there might be a connection that's there. So you have to be very careful on what you are installing in your machine. So for third-party components, you have to be very careful because most of them are not verified. If there are some that are secure, okay, there's nothing that's 100% secure. Let me not lie to you. So, but you have to do your due diligence. You have to go and see reviews by others, see what they found as well. But do your due diligence. There's some verified open source tools that you can be able to use around. So I have to know the specifics around what you want to achieve. Okay. So I'm not going to meet back between this session and lunch. I'll have one last question, and then we can close.
Thank you. I wanted to inquire, what are some of the best practices one would follow to prevent or control SQL attacks, SQL detection attacks, like to make it impossible for the input to alter the query?
To make it impossible, you have to put so many layers of protection on top. But you as a developer, you have to use parameterized queries in your code. So by parameterized queries, I mean you're not directly querying like the username and passwords. You are putting some form of quotations, like it's referencing a particular object. So that if it's compromised, like it's not directly related, so it's parameterized. So just go in and look at parameterized queries. But also, we have the OWASP top 10 application vulnerabilities. So this is usually done every 4 years, looking at the common security vulnerabilities that are attacking web applications. So you can go in, the first one is broken access control, geographic failures, injections. But in Python, the number one security vulnerability is around injection, especially around input validation. So, and then because you can be able to query that from your server side, from the queries that users input. So for Python specifically, number 3 is the top issue. But yes, so you can go in and look at OWASP top 10 vulnerabilities and learn what vulnerabilities are attacking web applications and which ones apply to Python. Okay? It's a wrap. So I had some cool names here. It's okay. So yeah. So sometimes you think like you put all these missions in place. You can see that guy is very well armored, but sometimes all it takes is a small space for an arrow to attack. So that's why you have to talk about defensive in-depth protection, because you have to put so many layers of protection. For us, you have to be lucky every time. For a hacker, you have to be lucky only once for them to compromise your system. So let's make it hard for them. Thank you.